The creation of a product or the design of a service needs to take into consideration many criteria. One of them is the protection of the environment. edTOOL is a web-based tool assisting the eco-design process. It includes brief instructions for each step of the process in order to guide the user through the methodology. Main users of edTOOL will be companies aiming to eco-design their products or their services. But the toolkit can also be used by public administration and policymakers. To start an eco-design project, the coordinator will first register his profile and then proceed with the initial definition. He will then build a team, including people from the whole value chain. Apart from having a consistent knowledge of the product and its life cycle, the team should also be aware of environmental issues. The ideal team should consist of a minimum of 5 members. Upon registration, each member will automatically receive a password to access edTOOL. Next, the coordinator describes the project and its objectives. At this point, a kick-off meeting would be helpful in order to support the development of further steps of the methodology. To complete the initial definition of the project, the team will select relevant criteria that will be later assessed in environmental terms. These criteria are sorted based on the typical life cycle stages of a product, from raw material to final disposal. The process of criteria customization should be done in a workshop session involving the whole eco-design team. Depending on the product and in line with the common agreement, the coordinator not only can add or remove criteria from the existing list that includes the most common topics, but also create custom ones. Once the team completes the criteria customization, the project can then enter its second step. In this step, all team members will individually make an assessment of the possible room for improvement for each cycle criteria previously defined, on a scale ranging from 1 to 5. The coordinator can, at any time, verify if all members of the team have completed this step. Once all the eco-design team members have assessed the life cycle criteria, one can get results. The results of the environmental assessment are presented in a summary table, showing the average score for each life cycle criteria and life cycle stage. 2 graphic representations of the results are available. The spider diagram will point out the life cycle stages and their relevant environmental performance. The criteria averages chart shows the average score of each life cycle criterion sorted in an ascendant order. Based on the previous environmental assessment, edTOOL suggests a series of environmental improvement strategies corresponding to the 2 life cycle stages with a worse environmental performance. The coordinator can also include predefined strategies for the life cycle stages that scored better. Furthermore, the coordinator can define custom strategies for each life cycle stage. The team will then check if the suggested strategies are appropriate for the assessed product and, if already applied, whether completed. These strategies will be evaluated for their social, economic, and technical viability on a scale ranging from 1 to 5. The team will also decide which strategies will be included in the action plan. In the following step, the team will define concrete actions to be carried out in order to implement the selected eco-design strategies, establish responsibilities and deadlines. Once the action plan is completed, the coordinator will move to the last step of the methodology. At this stage, a summary report composed of predetermined or customized parts of the methodology can be prepared. The results of the eco-design process, as shown in the final report, can help communicating the environmental performance level of the product. Being subjective and dependent on the capacity and experience of the team, edTOOL cannot compare to the more rigorous life cycle assessment tool. But edTOOL will guide companies through the process of eco-design implementation in a flexible and intuitive way, proposing assessment criteria and strategies together with real examples of eco-design projects. The potential benefits of using edTOOL include lower production and labor costs and greater efficiency, reduced material and resource costs, lower waste disposal costs, improved functionality and quality of products, easier and lower cost of compliance with legislation, easier disassembly and increased potential for recycling, more suitable product design life, increased market share, improved environmental performance, improved customer and supplier relationships, a better working environment and business culture. Using edTOOL can also lead indirectly to economic benefits, such as providing a useful marketing tool and encouraging innovation and product development.